Hey everyone, and welcome to a deep dive all about space. I hope you're ready for some cosmic fun because we're about to unpack a ton of fascinating information about the universe using a high school physics curriculum as our guide.
Sounds exciting.
It is. I think everyone is naturally curious about space and what's out there.
Yeah, definitely.
So today we're going to break down some basic concepts and hopefully spark even more curiosity about the vast universe we live in.
Awesome. Where should we start?
Well, our source material starts by defining the cosmic cast, all the major players in the universe.
Ah, okay. The who's who of space.
Exactly. So first up, we have planets. And I think we all know what a planet is, right? Like Earth, Mars, Jupiter.
Right, but there's a bit more to it. A planet has to orbit a star, and it reflects the star's light. It doesn't make its own light like a star does.
Okay, that makes sense. So what about those smaller objects like Pluto? It got demoted from planet status.
Pluto's a great example of a dwarf planet. It's orbiting the sun, but it's smaller and shares its orbital space with other objects.
So it's like it's not big enough to be in the planet club.
Pretty much. Like it didn't quite make the cut, but it's still out there doing its thing.
All right, planets and dwarf planets. Got it. Now, what about asteroids?
Asteroids are like the leftover bits and pieces from when the solar system formed.
Cosmic crumbs.
Exactly. They're much smaller than dwarf planets, and they're zipping around the sun.
Some of them even come close to Earth. Right. Okay, maybe that's getting a little ahead of ourselves.
Yeah, maybe a bit.
But it does make me think, where does our solar system fit in the grand scheme of the universe?
Well, our solar system is like our cosmic address. Our star, the sun, is at the center, and everything revolves around it.
So the 8 planets, dwarf planets, asteroids, comets, all that stuff.
It's like our little cosmic neighborhood.
Wow. So when we look up at the night sky, we're basically seeing our neighbors in a cosmic sense.
Kind of. It's crazy to think about the distances, though. If the sun were shrunk down to the size of a basketball, Earth would be like a tiny peppercorn orbiting it from like 25 meters away.
And Pluto.
Pluto would be like a grain of sand, way out there, like a kilometer and a half away. Space is huge.
That really puts things into perspective. Okay, so we've talked about planets, dwarf planets, asteroids, and our solar system. What about moons?
Ah, moons, they're natural satellites. They orbit planets.
Like our moon.
Exactly. And it's responsible for the tides on Earth.
Oh, wow. So every time I see the ocean tides, I should be thanking the moon.
You got it. Some planets have a bunch of moons, too, like Jupiter has over 70.
It's like its own little solar system.
It's pretty wild. But all this, the planets, moons, asteroids, it's just a tiny fraction of what's out there in the universe.
You're talking about galaxies, right?
Yeah, galaxies are massive collections of stars, gas, dust, and something called dark matter, and they're all held together by gravity. Our galaxy is called the Milky Way. It's home to billions of stars, including our sun.
Billions of stars just in our galaxy alone. And there are billions of other galaxies out there.
The universe is everything. All the galaxies, stars, planets, matter, energy, space, and time.
Okay, now my head is spinning. That's a lot to take in.
It is. Space is pretty mind-blowing.
But let's bring things back down to Earth for a second.
Okay, sure.
We hear a lot about satellites and how they're important for things like GPS. But what else do they do?
They're like our eyes in the sky, constantly observing Earth and sending back information. They're crucial for things like weather forecasting.
So they help us predict storms and stuff.
Yeah, they track storms, monitor climate change, even help predict natural disasters. They're essential for understanding our planet.
That's incredible. I had no idea satellites played such a big role. What about scientific discoveries like the Hubble telescope, for example?
Hubble is an amazing example. It orbits above Earth's atmosphere, so it can get super clear images of distant stars and galaxies.
Those pictures are always so stunning.
Right, and then there's the International Space Station, a laboratory in space. Astronauts do experiments up there in a zero-gravity environment. The ISS is a really cool example of international collaboration, too. You have astronauts from all these different countries working together up there.
It's like a symbol of unity in the vastness of space.
It really is, and we can't forget a lot of the technology developed for space exploration ends up benefiting us here on Earth, too.
That's right. I mean, I use GPS all the time, and I never really stop to think about the satellites making it all possible. It's mind-blowing when you think about it.
It really is, and it shows how important space exploration is, not just for the sake of knowledge, but for the practical benefits we get here on Earth. Speaking of discoveries, let's talk about light years. Have you ever heard of them?
Light years? Oh, yeah, but I've always had trouble understanding what they actually are. It's like a measure of distance in space, right?
You got it. It's the distance light travels in a year. And since light is the fastest thing in the universe,
How fast are we talking?
300,000 kilometers per second.
Whoa, that's incredibly fast. So like going around the Earth 7 times in a second.
Exactly. And over a whole year, that adds up to a distance of about 9.46 trillion kilometers. That's a light year.
Okay, wow. So if a star is, say, 10 light years away,
It means the light we're seeing from it left the star 10 years ago.
So we're basically seeing it as it was 10 years in the past.
Exactly. And when we look at stars that are millions or even billions of light years away, we're seeing them as they were millions or billions of years ago. It's like looking back in time.
So some of that starlight we see at night is like a message from before Earth even had dinosaurs. That's just, wow.
It really puts things into perspective, doesn't it? And speaking of starlight, did you know scientists can actually analyze the light from stars to figure out what they're made of?
Wait, seriously, how's that even possible? It's not like we can go grab a sample from a star.
It's all about something called spectroscopy. Every element in the universe has a unique light spectrum, like a fingerprint. When we split starlight with a prism or a spectroscope, it creates a spectrum with dark lines.
Like a rainbow.
Kind of, but these lines are like barcodes telling us which elements are present in the star's atmosphere.
So just by analyzing starlight, we can tell what a star is made of, even if it's trillions of kilometers away. That's amazing.
Pretty cool, right? Now, how about this question? How did all these stars and galaxies get here in the first place?
Yeah, how did everything begin? I've always wondered about that.
Well, the main theory is the Big Bang Theory. It suggests that the universe began as an incredibly hot and dense state about 13.8 billion years ago.
13.8 billion years. That's just, I can't even grasp that amount of time.
It's hard to imagine, right? But the Big Bang Theory says that all the matter and energy in the universe were squeezed into a tiny point, and then, boom, it rapidly expanded outward, creating space and time as it went.
So everything we see, all the stars and planets and galaxies, they all came from that one tiny point.
That's the idea. It's mind-blowing, isn't it?
It really is. So is the universe still expanding today?
It is, and scientists are still trying to figure out what the ultimate fate of the universe will be. Will it keep expanding forever, or will it eventually slow down and collapse back in on itself?
A collapse? Like a reverse Big Bang. Wow, I never even considered that.
There's still so much we don't know, but that's part of what makes studying the universe so fascinating.
Absolutely. Well, maybe we can zoom back in a little closer to home now. Our source material mentions the challenges and rewards of space exploration. What are some of the risks involved in sending humans into space?
Well, one big concern is the fuel. Rockets need a massive amount of fuel to escape Earth's gravity, and that fuel is a huge fire hazard.
So any problem during launch could be disastrous.
Exactly. The stakes are really high right from the start.
It makes you really appreciate the skill and bravery of everyone involved in these missions.
For sure. It's really inspiring to see people pushing the boundaries of what's possible.
But the risks don't stop once the spacecraft leaves Earth, right? I've heard about the dangers of radiation exposure in space.
Oh, absolutely. Space is full of radiation from the sun and other cosmic sources. Too much exposure to that radiation can be harmful to humans.
So how do they protect astronauts?
They have to have special shielding on their spacecraft, and the missions are planned to limit their exposure as much as possible.
It's amazing how many things you have to consider when planning a mission into space. It's not a simple task at all.
Definitely not. And there's another big challenge, too, the effects of microgravity on the human body.
Microgravity, you mean like weightlessness?
Yep. Without the constant pull of Earth's gravity, our bodies change. Bones and muscles can weaken, fluids shift upward, and even the cardiovascular system is affected.
I can imagine that being weightless would be pretty disorienting.
It definitely takes some adjusting. Astronauts go through extensive training to prepare for the challenges of microgravity. They have special exercise programs to help maintain their bone and muscle mass while they're up there.
It's amazing how adaptable the human body is.
It really is, but the long-term effects of space travel are still being studied. There's still a lot we don't know.
It makes sense that we're still learning. Now, our source material mentions something called a gravitational slingshot, which sounds pretty wild. What is that?
Oh, it's a cool technique that uses the gravity of planets and other celestial bodies to help propel spacecraft.
So you can use a planet's gravity to speed up a spacecraft.
Exactly. It's like a cosmic game of billiards. You can use a planet's gravity to slingshot the spacecraft in a new direction and increase its velocity.
Wow. So it's not just science fiction. It's a real technique they use?
Oh yeah, they've used it on several missions, like the Voyager probes that explored the outer planets of our solar system.
That's incredible. And it also highlights just how much careful planning and calculation goes into space travel. It's not like hopping on a plane.
It's way more complex. But that's what makes it so fascinating. We're constantly pushing the limits of what we know and what we can do.
It definitely sounds challenging. Speaking of challenges, what about docking a spacecraft with the International Space Station? I imagine that's incredibly difficult.
Oh yeah, docking with the ISS is one of the trickiest maneuvers in spaceflight. It requires amazing precision and timing. Remember, both spacecraft are moving at really high speeds.
So it's like trying to, I don't even know, trying to parallel park on an ice rink while wearing a blindfold?
Haha, something like that. There's no room for error because a collision could damage both spacecraft. It could even be dangerous for the astronauts on board.
So how do they make sure the docking is successful?
It's a combination of careful planning, advanced technology, and the skill of the astronauts and the ground control teams. They use radar, lasers, and cameras to track each other and make tiny adjustments to ensure a safe docking.
It sounds like every little detail matters in space.
It really does. And amidst all the incredible technology, it's important to remember that space travel also presents some very real dangers, like the pressure difference between a spacecraft and the vacuum of space.
A vacuum, so there's no air pressure at all in space.
That's right, it's completely empty. And because our bodies evolved to function with Earth's air pressure, the exposure to a vacuum could be really dangerous.
Dangerous how? What would happen?
Well, without that air pressure, fluids would boil, gases in the mud would expand, the lungs would struggle to work. It wouldn't be good. It highlights why airtight spacecraft and spacesuits are so important for protecting astronauts.
It's a good reminder that space is a pretty harsh environment. But despite those dangers, there's still so much we want to explore.
Absolutely. That drive to explore is a big part of what makes us human. It's what led our ancestors to cross oceans and explore new lands, and it's what pushes us to reach for the stars today.
And as we explore, we make discoveries that benefit us here on Earth, too.
Exactly. Think of all the technology that came from space exploration. Satellite communication, GPS, medical imaging, advanced materials, it's all thanks to space research.
It's amazing how studying space can lead to innovations that improve life here on Earth.
It really shows that investing in space exploration isn't just about satisfying our curiosity. It's also about making our lives better, both now and in the future.
Absolutely. Well, I think we've covered a lot of ground today, from the basic building blocks of the universe to the complexities of space travel. It's incredible to think how far we've come in our understanding of space.
It really is. We've gone from wondering about the stars to sending robots to other planets and even having humans living and working in space.
It's a truly remarkable journey of discovery.
It really is. And it's a testament to the power of human curiosity and ingenuity.
Well said. And remember, you don't have to be an astronaut or a scientist to be a part of this adventure.
That's right. Keep looking up at the night sky, keep asking questions, keep that sense of wonder alive.
Exactly. You never know what amazing discoveries are waiting to be made.
That's the beauty of it. The universe is full of mysteries, and the exploration never really ends.
I couldn't agree more. Well, that wraps up our deep dive into the universe for today. We hope you enjoyed the journey.
We'll see you next time for another cosmic adventure. And all that tech, it often finds its way back to Earth. It improves our lives in ways we don't even realize.
You're right. Like, I use GPS almost every day. I never stop to think about the satellites making it possible. It's like this network of tiny robots up in space, constantly beaming down info. Mind-blowing.
It is. It shows how crucial space exploration is, not just for the sake of knowledge, but for the practical benefits we get right here on Earth.
For sure. Okay, so shifting gears a bit, let's talk about light years.
Ah, light years, always a fun one.
I know it has something to do with distances in space, but I've always struggled with the concept. Can you maybe shed some light on it for me? No pun intended.
Of course. A light year is simply the distance light travels in 1 year. And since light is the fastest thing in the universe, traveling at 300,000 kilometers per second.
Wait, hold on. 300,000 kilometers per second. That's like going around the Earth 7.5 times in 1 second.
Exactly. It's insanely fast. And over a year, that speed adds up to a distance of about 9.46 trillion kilometers. That's 1 light year.
Okay, I think I'm starting to get it. So when we say a star is, let's say, 10 light years away.
It means the light from that star took 10 years to reach us.
Ah, so we're seeing it as it was 10 years in the past.
Precisely. And this is where it gets really cool. When we look at stars that are millions or even billions of light years away, we're actually seeing them as they were millions or billions of years ago.
So, like, some of the starlight we see is a message from a time before Earth even had dinosaurs.
It's mind-blowing, isn't it? We're literally looking back in time.
It really is. Now, this might sound like a silly question, but can scientists tell what stars are made of just by looking at them?
Not a silly question at all. It's all about spectroscopy. Every element in the universe has a unique light spectrum, like a fingerprint. When we pass starlight through a prism or a spectroscope, it splits into different colors, creating a spectrum.
Oh, like a rainbow.
Sort of, but instead of a smooth blend of colors, a star's spectrum has distinct dark lines. Those lines act like barcodes, revealing the specific elements present in the star's atmosphere.
So we can tell what a star is made of just by looking at its light.
Exactly. Even in that star is trillions of kilometers away.
Wow, science is amazing. Okay, so we've talked about stars, but what about the bigger picture? How did all these stars and galaxies even form in the first place?
That's a question that's kept scientists busy for centuries. The leading theory is the Big Bang Theory. It suggests that the universe started as an incredibly hot, dense state about 13.8 billion years ago.
13.8 billion years. I can't even wrap my head around that number.
It's a really long time. But the Big Bang Theory says that all the matter and energy in the universe were packed into this tiny, tiny region, and then suddenly it expanded outwards rapidly.
So everything we see today, all the stars and galaxies, came from that one tiny point.
Yep, that's the basic idea. Mind-blowing, isn't it?
It really is. And is the universe still expanding today?
It is. But how it will all end, that's a mystery. Some scientists believe it will keep expanding forever. Others think it might eventually slow down and collapse back in on itself.
Collapse. Wow, that's kind of terrifying.
It is a pretty intense thought. For now, though, let's focus on our own little corner of the universe, our solar system. Our source material talks about the challenges and rewards of space exploration. What are some of the biggest risks of sending humans out into space?
Well, space is a pretty harsh environment. One major concern is the fuel load required for liftoff. Rockets need an enormous amount of fuel to break free from Earth's gravity, and that fuel is a huge fire risk. So any issue during launch could be really bad.
Exactly. The risks are incredibly high from the very beginning.
It makes you appreciate the courage it takes to be an astronaut or work in the space program.
Absolutely. It's inspiring to see people pushing the boundaries of what's possible, even in the face of those risks.
But the risks don't disappear once a spacecraft is in space, do they? What about the dangers of radiation exposure?
That's a big one. Space is filled with radiation from the sun and other cosmic sources. Spending too much time exposed to that radiation can have serious consequences for human health.
So how do they protect astronauts from that?
Well, spacecraft have to be equipped with special shielding to block as much radiation as possible. And missions are planned to minimize the amount of time astronauts spend in high radiation areas.
It's amazing how much goes into planning these missions. It's a whole other level of complexity compared to, say, flying a plane.
Oh yeah, for sure. And then there's another big challenge, the effects of microgravity on the human body.
Microgravity, you mean like weightlessness?
Exactly. Without the constant pull of Earth's gravity, our bodies change in all sorts of ways. Bones and muscles can weaken, fluids shift around, and the cardiovascular system is affected.
I bet it feels pretty strange to be weightless after a lifetime of living with gravity.
It definitely takes some getting used to. Astronauts go through a rigorous training to prepare for the challenges of microgravity, and they have special exercise routines they do in space to help maintain their muscle and bone mass.
It's incredible how adaptable the human body is, though.
It really is, but we're still learning about the long-term effects of space travel on the human body. There's a lot we still don't know.
It makes sense that we're still figuring things out. Okay, so our source material talks about something called a gravitational slingshot, which sounds like a pretty wild way to travel through space. Can you explain how that works?
It's a really clever technique that harnesses the gravitational pull of planets and other celestial bodies to help propel spacecraft.
So you could use a planet's gravity to give a spacecraft a speed boost.
Precisely. It's like a cosmic game of billiards. You can use a planet's gravity to slingshot the spacecraft in a new direction and increase its speed.
So it's not science fiction, it's actually something they use.
Oh, it's a real thing. It's been used successfully on many missions, including the Voyager probes that traveled to the outer planets of our solar system.
Wow, that's incredible. And it shows just how much careful planning goes into space travel. It's not like simply pointing a spacecraft in the right direction and hitting the gas.
It's way more complex than that, but that complexity is also what makes it so fascinating. It's a constant challenge to push the limits of what we know and what we can do.
Speaking of challenges, how about docking with the International Space Station? That has to be incredibly difficult.
Docking with the ISS is one of the most delicate and demanding maneuvers in spaceflight. It requires incredible precision and timing because both spacecraft are moving at really high speeds.
I can only imagine. It sounds like trying to, I don't even know, like trying to parallel park on an ice rink while blindfolded.
Haha, something like that. There is absolutely no room for error because a collision could damage both spacecraft and it could be dangerous for the astronauts on board.
So how do they manage to pull off something so precise?
It takes a combination of careful planning, advanced technology, and the exceptional skill of the astronauts and the teams on the ground. They use radar, lasers, and cameras to track each other's positions and make small adjustments to ensure a smooth and safe docking.
It's really amazing what humans can achieve when they put their minds to it. But even with all our technology and expertise, space travel still presents some serious dangers. What about the difference in pressure between a spacecraft and the vacuum of space?
That's a critical consideration. A vacuum is an area completely devoid of matter, including air. And since our bodies are designed to function in Earth's atmosphere with its specific air pressure, exposure to a vacuum can be catastrophic.
Catastrophic how? What would happen if an astronaut was exposed to the vacuum of space?
Well, imagine your body suddenly exposed to that environment, fluids boiling, lungs collapsing. It wouldn't be pretty. Without the external pressure of the Earth's atmosphere, bodily fluids would start to boil, gases dissolved in the blood would expand rapidly, and the lungs would struggle to function.
Yikes, that paints a pretty vivid picture of why airtight spacecraft and spacesuits are so crucial.
Absolutely. They're essential for protecting astronauts from the unforgiving environment of space. It's a stark reminder that space is a very alien and potentially hostile place.
It makes you really appreciate the challenges and risks involved in space exploration. But despite the dangers, we're still drawn to explore, aren't we?
We are, and that drive to explore is really a fundamental part of what makes us human. It's the same curiosity that led our ancestors to cross oceans and explore new continents, and it's what drives us to reach for the stars today.
And as we explore space, we're not just satisfying our curiosity, we're also making discoveries that have real, practical applications back here on Earth.
Exactly. Space exploration has given us countless technological innovations that have benefited humanity in countless ways. From satellite communication and GPS navigation to medical imaging and advanced materials, the ripple effects of space research can be seen in almost every aspect of modern life.
It really showed that investing in space exploration is not just about expanding our knowledge of the universe, it's also about improving our lives and creating a better future for generations to come.
Precisely. And as we continue to push the boundaries of space exploration, we can be sure that there will be even more incredible discoveries and innovations that will benefit us in ways we can't even imagine today.
It's amazing to think that something like, studying distant stars can lead to breakthroughs that actually improve our lives right here on Earth.
It's a perfect example of how investing in space exploration really is investing in our future. And it's not just about, tangible benefits either. It's also about the inspiration. Think about those iconic images from the Apollo missions, humans walking on the moon.
Yeah, those pictures are incredible.
They captured the imaginations of people all over the world. They sparked dreams of space travel for a whole generation.
You're right, it makes you realize that nothing is impossible. But space exploration isn't just about those big missions, like Apollo. It's also about the everyday work happening up on the International Space Station.
That's a great point. The ISS is this amazing achievement. Think about it. It's a microgravity laboratory where astronauts can do experiments in all sorts of fields: biology, physics, materials science, you name it.
So what kind of experiments are they actually doing up there? I'm picturing astronauts floating around mixing colorful liquids in test tubes.
Well, it's a little more sophisticated than that, but the microgravity environment provides unique opportunities for research. For example, they're studying how plants grow in space.
Space gardening. Sounds cool.
It is. It could help us figure out how to grow food on future long-duration missions. Imagine, like, a mission to Mars.
That would be incredible. What about those other experiments you mentioned, like the physics and materials science stuff?
Well, scientists are using the ISS to learn how fluids and flames behave differently in microgravity.
Why is that important?
Well, for one thing, it can help us develop more efficient engines, and they're experimenting with new materials up there too. It could lead to, like, advancements in electronics or even construction.
The possibilities are pretty endless, huh?
They really are. Our source material also talks about something I find pretty fascinating. They say it might be possible to use a sort of catapult from a fast-moving asteroid or moon or planet to help spacecraft achieve really high speeds for space travel.
Wait, you mean like a gravitational slingshot? We talked about that earlier, right?
Exactly. Remember, we compared it to a cosmic game of billiards using gravity to give a spacecraft a speed boost.
I remember. It's amazing how we can harness these laws of physics to navigate through space.
It's incredible. The gravitational slingshot will probably be a key technique for traveling to far-off destinations, both within our solar system and maybe even beyond.
It's like a cosmic road trip. But even with techniques like that, space travel still has so many challenges, right? Like, how do you even steer a spacecraft in an environment with zero friction?
Oh, that's a huge challenge. In space, there's no air resistance or friction to slow things down or keep them stable. Even a small nudge can send a spacecraft off course. That's what makes things like docking with the International Space Station so difficult.
Yeah, docking with the ISS, that sounds incredibly stressful. Like trying to, I don't even know, like trying to parallel park a car on an ice rink while wearing a blindfold.
Haha, that's actually a pretty good analogy. It takes incredible precision and skill. The astronauts and the engineer have to calculate every little movement, every tiny adjustment to make sure the docking is safe and successful.
It really shows what humans are capable of when we work together and push ourselves to the limits.
Absolutely. And as we think about the future of space exploration, it's exciting to imagine what new technologies we might need to overcome these challenges and venture even further into the cosmos.
It makes you wonder what other incredible discoveries are waiting out there.
That's the beauty of it, right? The universe is full of mysteries, and our exploration is never truly finished.
Well, I think we've covered a lot of ground today, from the basics of the universe to the challenges of space travel. It's been an incredible journey.
It has, and I hope our listeners are feeling a little more inspired and maybe a little more curious about the cosmos.
Me too. And remember, you don't have to be an astronaut or a scientist to explore and appreciate the wonders of space.
That's right. Keep looking up at the night sky, keep asking questions, and keep that sense of wonder alive.
Beautifully said. And until next time, this has been The Deep Dive, signing off.